Okay. I'm recording all of these in one day, but I'm gonna be posting them as assignments next week. So I just finished talking about two by two. Now I said I was gonna keep them in the same lesson, but I think I decided that we're gonna split up the two by two and three by three lessons to 2 different days. So today is a new day. All right. All right, so we're going to move on to Cramer's rule for a 3 by 3 system. All right, so now instead of yesterday, we were talking about how to use Cramer's rule for two variables, x and y. All right, so we have a 2 by 2 coefficient matrix. All right, today we're going to be talking about how to use Cramer's rule for a 3 variable system. So we're going to have x's, y's, and z's. All right, so our coefficient matrix is going to end up being bigger. It's going to be a 3 by 3. Now, of course, we all know that finding 3 by 3 matrix, the determinants for a 3 by 3 matrix is a little bit more difficult. It's not too hard, but it requires a little bit more work than a 2 by 2. All right, but we're going to find out some tricks. Solving a 3 variable system of equations, if we don't use the Cramer's rule, is possible, but it's complicated. It takes a lot of algebra writing a bunch of stuff. So today we're going to use the Cramer's rule, which makes it simpler. Still requires a bit of work, but it's simpler. All right, so the first thing, we're going to say that A is the coefficient matrix of a linear system. All right, like this. So what is A going to look like? Well, if A is the coefficient matrix of this, A is going to look... I'm going to draw it like this. All right, A is going to look like this. It's going to be A, because A times X, B times Y, C times Z. So C. And then same thing all the way down. A, B, C, D, E, F, and then G, H, I. G, H, I. Now you need to make sure that when you are writing out your coefficient matrix, you need to all the x's, the coefficients for the x's all have to be in one column. The coefficients for the y all have to be in one column, and the coefficients for the z's all have to be in one column. You can't mix it around. If they wrote if they write 3x plus 4y minus 2z equals blah, 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 and then 3z minus 4x plus 5y, they mix things around, the x's and the y's. You need to make sure you put them all in order before you make your matrix, all right? Now, as long as if we take the determinant of this, as long as it's not equal to 0, then we know that this has a solution. That we can find the x, y, and z, right? And it has exactly one solution, and we can find that solution in a certain way. Now, this gets a little bit tricky, so pay attention. All right, we're going to be making 3 different matrices. All right, one we're going to call dx, another we're going to call dy, and the last one we're going to call dz. All right, so pay attention how to do this. How do we find dx? Well, dx is going to be the same as a. The only difference is that we're going to take out, just like up here, remember we had to take out the x ones and we had to replace it with the e and the f over here. We're going to do the same thing here. So we're going to, for dx, we're going to take out all of these, and we're going to take this and we're going to put it there. All right? So it's going to be J, K, L, and then everything else is the same. B, C, E, F, and H, I. All right, so that's that matrix. All right, then guess what? DY is done the same way. All right, this time we're going to keep the x's, so we're going to have the coefficients are a, d, g. All right, but now we're going to get rid of the y's because this is dy. We're going to get rid of the y's and we're going to put in the jkl. So this is going to go by and we're going to put jkl. And then this column is going to stay the same still. So it's going to be C, F, I. All right, and then finally, our DZ is going to be done the same way. All right, we're going to keep everything in the first two columns. So this is going to be A, B, D, E, and G, H. But then our last column, we're going to take away these Z's and we're going to put in the JKL. All right, JKL. So you can see here that dx, dy, dz, they're the same as this A matrix. The only difference is that for the x1, we're going to take out the x's and we're going to put in the JKL. For the y1, we're going to take out the y's and put the JKL in. And for the z1, we're going to take out the z coefficients and put the JKL in. All right? So that's how you find these matrices. Now, after you have found all of these matrices, our final solutions are going to be that x is going to be the determinant, all right? It's going to be the determinant of dx over the determinant of A. All right? And then y is going to be the determinant of dy over the determinant of A. And z is going to be the determinant of dz over the determinant of A. Okay? So it requires us to find lots of determinants. All right? We have to find the determinant for this one, this one, this one, and this one. We're going to have to find 4 determinants. But once we find those 4 determinants, it's easy to find x, y, and z. All right, we can solve for it. So we're going to go ahead and move on to doing a couple of examples. All right, one of the examples is just a problem. The other one is going to be a word problem. All right, so let's first do this one. So I suggest that we first just find out all of our determinants. All right, so and then we'll solve for x, y, and z. So I'll show you how to do that. First thing we're going to do is we're going to find the determinant of A. So I'm going to say the determinant of A is going to equal, and then we're going to write out our A matrix. Now, what's our A matrix? It's going to be 1, 3, negative 1, 1, 3, negative 1, and then negative 2, negative 6, 1, negative 2, negative 6, 1, and then 3, 5, negative 2, 3, 5, negative 2. All right, so we want to find the determinant of that. Now remember, how do we find the determinant of that? Well, we're going to go 1 times, and we cross this out, and we have our little matrix in the middle. So we're going to find this one. So negative 6 times negative 2 is 12 minus 1 times 5 is 5. So 12 minus 5. 12 minus 5 is 7. And then we're going to minus 3 times the determinant of, if we cross this out and this out, what's left? So we have negative 2 times negative 2. That's 4 minus 1 times 3 is 3. 4 minus 3 is 1. All right. And then we're going to plus, well, actually, it's going to be, there's a minus here, so it's going to be negative 1 times, and then if we cross this out and this out, we left with this thing here. So we're going to negative 2 times 5 is negative 10, and we're going to minus negative 6 times 3. Negative 6 times 3 is negative 18. So it's negative 10 minus negative 18. That's negative 10 plus 18. That's 8. So now we have our determinant. It's going to be 7 minus 3 minus 8, right? 7 minus 3, that's 4. And then minus 8, so that's negative 4. All right, let me make sure I got that right. Yeah, negative 4. All right. Now, so that's our A, but we also need to find dx, dy, and dz. So we have a lot of determinants to find. All right, so let's do dx next. All right, so we want to find the determinant of dx. All right, now, so we want to find the determinant of the dx matrix. Now, how do we find the dx matrix? Now, remember, for dx, we're going to take out all of the x ones. So this one, and this one. 1, negative 2, and 3. And we're going to replace it with the answer, the ones on the other side, all right, of the equal sign. So we're going to have 1, negative 3, 4. So take this away, and we're going to have 1, negative 3, 4. And then the rest of the matrix is the same. So we have 3, negative 1, 3, negative 1, negative 6, 1, negative 6, 1, and then 5, negative 2, 5, negative 2. All right, so now we just find this determinant. All right, equals. My dogs are barking. Let me close my door real quick. I forgot to close the door. All right, so let's keep going. So let's again, how do we do this? We're going to say 1 times, so we 1, and then we cross everything out. We have negative 6 times negative 2 is 12, minus 1 times 5 is 5. 12 minus 5 is 7, all right? Then we're going to minus 3 times, and if we cross out everything in the 3 row and 3 column here, we're going to have negative 3 times negative 2, that's 6, minus 1 times 4, 4. 6 minus 4 is 2. And then we're going to plus negative 1, which is minus 1 times, and if we cross everything out here and here, we have negative 3 times 5 is negative 15, minus negative 6 times 4 is negative 24. Negative 15 minus negative 24 is negative 15 plus 24, which is 9. All right, so then we're going to add these together. So we have 7 minus 6, that's 1, minus 9 is negative 8. All right, so this is going to be negative 8. So the determinant of dx is negative 8. All right, now we're going to find the determinant of dy. All right, determinant of dy. Now, how do we find the determinant, or how do we find dy? Again, we're just going to take out all of the y coefficients, so 3, negative 6, 5. We're going to take that out, and we're going to place it with 1, negative 3, 4. So everything else stays the same. So we have 1, negative 2, 3, 1, negative 2, 3, and then we have 1, negative 3, 4, 1, negative 3, 4, and then the third column stays the same. Negative 1, 1, negative 2. And that equals, all right, now we just need to find the determinant. So that's going to be 1 times, and we're going to do negative 3 times negative 2, 6, minus 1 times 4. So 6 minus 4 is 2. And then we're going to minus 1. All right, there's a 1 here. So we're going to minus 1. All right, and then we're going to have, if we cross everything out here and here, we're going to have negative 2 times negative 2 is 4. And then 1 times 3 is 3. 4 minus 3 is 1. And then we're going to have plus negative 1. So that's negative 1 minus 1. And then we're going to do the determinant of this one right here, because we cross this out, we have this. So negative 2 times 4 is negative 8, and then negative 3 times 3 is negative 9. So negative 3 minus negative 9 is negative 8 minus negative 9 is negative 8 plus 9, which is 1. All right, so we're going to have 2 minus 1 minus 1, which is 0. Now, I said a can't be 0, but dx or dy or dz, they can be 0. It's okay because we're going to be dividing by a. So the 0 can't be on the bottom, but it's okay if the 0 is on the top. That's not a problem. So this is okay, all right? Final thing we need to find now is dz. All right, we want to find the determinant of dz. All right, now how do we find dz? All right, remember it's going to be the same as this one. So we're going to have 1, 3, negative 2, negative 6, 3, 5. But we're going to take away the last column, the z coefficients, and we're going to replace it with 1, negative 3, 4. The answers over here. So 1, negative 3, 4. Okay? Not the answers, but the numbers on the other side of the equation. Okay, so we have our dz matrix. We can find its determinant now. Again, we're going to start with 1 right here. We're going to cross everything out, and we got negative 6 times 4. What's negative 6 times 4 is minus 24. And then we're going to subtract negative 3 times 5, which is negative 15. So we have 24 minus 15. Wait, I'm sorry. Negative 24 plus 15. All right. Negative 24 plus 15 is negative 9, right? Yeah, I think negative 9. All right, so we have negative 9. All right, and then we're going to minus 3. All right, so we minus 3 now. And then we're going to cross this out, and find the determinant. So negative 2 times 4 is negative 8. Negative 3 times 3 is negative 9. Negative 8 minus negative 9 is negative 8 plus 9, which is 1. All right, and then the final part, we're going to have plus 1 times, and we're going to cross this out, and find this determinant. So negative 2 times 5 is negative 10. Negative 6 times 3 is negative 18. So we're going to have negative 10 minus negative 18, which is negative 10 plus 18, which is positive 8. All right, so we're going to have minus 9 minus 3, which is negative 12, plus 8. So it's going to be minus 4, I believe. Yeah, minus 4. Okay, so we have found all the determinants. So that's the long part. Now the easy part is just finding x, y, and z. So we know that x is going to be the determinant of dx over the determinant of a, which in this case is dx is negative 8, and the determinant of a is negative 4, so it's going to be negative 8 divided by negative 4, which is positive 2. All right, and then y is going to be the determinant of dy over the determinant of a. All right, so the determinant of dy over the determinant of a, that's 0 over negative 4, which is just 0. All right, and then the last is z is going to equal the determinant of dz over the determinant of a. Well, the determinant of dz is negative 4. The determinant of a is negative 4. So that just equals 1. So our final answer is that x equals 2, y equals 0, and z equals 1. All right, let me make sure. 2, 0, 1. Yep, that's correct. And we are done. All right, so that's how you do this. It's a little bit long, takes a little time, but it can be done. We're going to do one more example. This is a word problem. All right, so this one's you have to use your brain a little bit. You have to know a little bit about chemistry. All right. So it says the atomic weights of 3 compounds are shown. All right. Use a linear system and Cramer's rule to find the atomic weights of carbon, hydrogen, and oxygen. So our 3 variables here are going to be C, G, and O, not X, Y, Z. All right. So how are we going to do this? Well, here it tells us that methane weighs 16, and we know that it has 1 C and 4 H's, all right, which is G. All right, so we know that it's going to be C plus 4G, all right, is going to equal 16, all right? Then let's look at this one. We have 3 C's plus 8G plus 3 O's. All right, 3, and I'm gonna try and make this look like an O. All right, not like it's not a 0, it's an O. All right, so 3C plus 8G plus 3O is going to equal 92. And then finally, we know that 2G plus 1O, not 0, this is an O, all right, equals 18. All right, so this is our system of equations that we need to solve, and we're going to use Cramer's rule to solve it. All right, how are we going to do that? Well, we just need to make a coefficient equation matrix first. All right, so A, our matrix, is going to be now all the C's in the first column. Now in this one we have 1 C, and this one we have 3 C's, and this one we have 0 C's. So we're going to put a 0 here. All right. All right. Next, we're going to put all of our G's in the next column. So we have 4 G's here, 4. And then we have 8 G's. And then we have 2 G's. And then our last column, we're going to put all of our oxygens. All right. So in this one, we have 0. In this one, we have 3. And in this one, we have 1 oxygen. All right. So this is our A matrix. All right. All right. So now let's find, I'm not going to call them dx, dy. I'm going to call them d, and then I'm going to use the variable that we're using. So let's find dc first. All right. Real quick, I'm going to, at the top of here, I'm going to write that this is C's, this is G's, and this is the oxygen so that I can remember everything. All right, so what is our DC matrix going to look like? Actually, let's not just find our DC. Let's find the determinant of DC. All right. So what's the determinant of DC? Well, the DC is going to be, we're going to take out the C's and we're going to put 16, 92, and 18. All right, and I'm just now realizing that these are going to be some big numbers, so I'm probably going to have to pull out my calculator. All right, so we're going to have 16, 92, 18, and then the rest of this is going to stay the same. So it's going to be 4, 8, 2, 0, 3, 1. All right, and so we're going to have to find this. All right, now I'm going to have to use my calculator here, so let me get this out. I know this video is going to be much longer than our other videos, but we have to get through all this today. All right, so how do we find this? It's going to be 16 times, and then we're going to use 8 and 3 times 2, right? Because we're going to cross this out. We have 8 minus 6, so it's going to be 2. And then we're going to have minus 4, and then we're going to have to find 92 times 1, so that's 92, and then 3 times 18. 3 times 18 is 54, all right? So we have 92 minus 54. What's 92 minus 54? I can in my head. 36? Yes, right? 92. Let me check it. 92 minus 54 is 38. Dang it. See, good thing I checked. Oh, actually, let me erase that. 38. All right. And then we're going to plus 0 times blah, 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 blah. But 0 times blah, blah, blah is going to be 0. So we don't even need to mess with this. All right. So we're done there. So it's 32. I'm going to multiply this out on the calculator. So we have 32 minus 4 times 38, which is negative 120. All right. So this is negative 120. All right, great. So that's the determinant of DC. Now we're going to find DG, all right? And we want to find the determinant of DG, all right? And that's going to equal, now we're going to have 1, 3, 0 here, 1, 3, 0. And then in the middle for our G's, because this is DG, we're going to replace it with 16, 92, and 18. All right. And then our last column is going to be 0, 3, 1 again. All right. So let's find this. All right. We're going to have 1 times, and then we're going to do 92 times 1, and then 3 times 18. Now, 3 times 18 is 54. So we have 92 minus 54 again, and we just said that's 38, right? Yeah, 38. All right, so this is going to be 38. All right, and then we're going to minus 16, because we have 16 up here now. All right, we're going to minus 16 times, and we're going to cross this out, We're going to have 3 times 1, which is 3, minus 3 times 0 is 0, so 3. All right, and then we're going to plus, and we have 0 here again, so we don't need to worry about that. So we're just going to keep that out. And we're going to have 38 minus, now that's 18, 48? Yeah, 48. 38 minus 48, which is negative 10. Okay. And then the last, well, actually, we still haven't found the determinant of A yet, but the last one of these we need to find is the determinant of oxygen, the deoxygen, all right, which is going to be, keep everything the same, 1, 3, 0, keep it the same as up here, 4, 8, 2, but then the last row, the oxygen row, we're going to replace with the solutions, 16, 92, 18. All right, and we need to find that determinant. All right, now how do we find that? Well, it's going to be 1 times, and this one's going to be bigger, so 8 times 18. All right, I'll just do this on the calculator. 8 times 18 minus 92 times 2, which becomes negative 40. All right, so this is negative 40. And then we're going to minus 4 times, and then we cross out this, we have 392, 0, 18. So we're going to have, I'm going to, again, use my calculator. We're going to do 3 times 18. Oh, we don't need it. And then minus 92 times 0 is 0. So the answer is just going to be 3 times 18, which is 54. All right, and then finally, we're going to plus 16, this one, times, and then we're going to take the determinant of this, which is 6 minus 0. So it's just 6. All right, so we can now calculate this. We have negative, I'll use a calculator again. All right, we're going to have negative 40 minus 4 times 54. And then we're going to plus 16 times 6. And we get negative 160. Negative 160. All right, now the last thing we need to do before we find our answers is we need to find the determinant of this one. We need to find the determinant of A, right? All right, so we're just going to look up here. We're going to have 1 times, and then it's got 8 minus 6, right? 8 minus 6 is 2. And we're going to minus 4, and we're going to 3 times 1 minus 3 times 0, so that's 3. And then plus 0, blah, 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 blah. So we don't need 0 times anything is 0, so we don't need to worry about that. All right, so we're going to have 2 minus 12, right? 2 minus 12, which is negative 10. All right, so now we have everything we need to find our answers. So we can find the weight of the carbon is going to be negative 120 divided by negative 10, which is just 12, right? And then hydrogen, all right, which is our G, all right, the weight here, all right, the weight here, I don't know why did they use G for hydrogen instead of just H? I don't know. All right, is going to be negative 10 divided by negative 10. Negative 10 divided by negative 10, which is positive 1. And then our oxygen, all right, our oxygen is going to be negative 160 divided by negative 10, which is positive 16. All right, and this is the answer that we were looking for. These are the atomic weights for carbon, hydrogen, and oxygen. All right, that's everything. 32-minute long video. I'm sorry this one's a little bit longer, but we had to go through all this. I will see you guys next time.